Hi everyone, and welcome to our first video lecture for the semester for Math 100. This is section 1.2. So in these videos, really I'm just going to be going over some problems. I'll talk about a little bit of the theory, but I'm mainly going to be doing problems and examples that will be very close to what you'll see on your homework and in quizzes and stuff. So, for the first example here in section 1.2, this section 1 is really going to be about lines and linear functions. So what we'd like to do is we'd like to graph the line given by the equation y equals 6x minus 3. And remember what this is a line really is going to correspond to a set of points in this plane, this xy plane, which we sometimes call the Cartesian plane. So let's say if we just want to start out by, for that brute force, what we do is plot some points. And you don't have to plot too many points because we know that 2 points draw a line. So if you had to have 2 points, if you draw a line connecting those 2 points and then extend it, that's usually enough. But let's plot some a bunch of points. So we'll pick some x values, and then we'll see what the corresponding y values are. So let's take 0, 1, 2, 3, and maybe some negative numbers like -1 and -2. And what we do is we plug all these values in here. So when x equals 0, y is going to be 6 times 0 minus 3. That's -3. When x is 1, we get 6 minus 3. That's going to be positive 3. When x is 2, you get 6 times 2, that's 12. 12 minus 3 is 9. When x is 3, you get 6 times 3, that's 18. 18 minus 3 is 15. When x equals -1, we get -6 minus 3, that's -9. And -2, when x is -2, we get -12 minus 3, that's -15. Okay, so what we could plot all of these points, but let's just maybe plot these first two and see what we get. So we take, when x is 0, that means the x coordinate is 0 and the y coordinate is -3. So we're at this point right down here. Next, when x equals 1, y equals positive 3. And really, we can see there's a line. We can draw the line connecting these 2 points, and then extend them in a way like this. If we wanted to plug in 2, 9, you could check that would be way up here. That point would be way up here. All right. So now we'll eventually find out how a little easier way, slightly easier way to graph this line when we talk about slope. Okay. But basically, if you can find 2 points on a line, that's enough to graph it. Next one, let's say we wanted to find the x and y intercept of the line given by y equals -2x plus 5. Okay, well, so let's remember how to do that. So for the y-intercept, let's do the y-intercept first because that's easier. For the y-intercept, you set x equals 0 and solve for y. And then for the x-intercept, it's the reverse. Set y equals 0 and then solve for x. Okay. All right. So in the first, for the y-intercept, if we set x equals 0, well, that's not hard, right? We will get y is equal to -2 times 0 plus 5. That just tells us that y equals 5. Okay, so that will be the y-intercept. And if we set y equals 0, we get y equals -2x plus 5. Now we have to do a little bit of algebra. We can add 2x to both sides and get 2x equals 5 because these 2x's cancel, and then divide both sides by 2. and we get 5/2, which we can, if you want to write this as a decimal, would be 2.5. Okay, so that would be the x-intercept. Now, to be a little more precise, the x-intercept and y-intercept are points, and points have two coordinates, an x-coordinate and a y-coordinate. So the y-intercept, really, since x is 0, we give it by the point 0, comma 5 in this case. And the x-intercept would be 2.5. The x value would be 2.5, and the y-coordinate would be 0. Okay. And then we can plot these points, these 2 points on the graph. So 0, 5 is up here. 2.5 is halfway between 2 and 3. And then we can draw the line connecting these 2 points. Okay. So that would be our line. All right. Now, there are a couple of degenerate cases here. Let's say we wanted to graph the lines x equals 3 and y equals 4. What this is, so there are 2 lines here we're talking about. When you see an equation given by x equals some number, we're talking about a vertical line, because we're talking about all the points where the x-coordinate is 3. So for x equals 3, okay, so here's 3, the coordinate, the point 3, 0, okay, and everything on this vertical line has x-coordinate equal to 3. So that's why we have a vertical line. And then similarly, for y equals -4, when you ever have y equals a constant, that's a horizontal line because all the y-coordinates are the same. So here's 1, 2, 3, 4. Here's what, -4. And talking about this this horizontal line right here. Okay, and now that we've graphed these lines, it's pretty easy to see what the intercepts are. The x-intercept here will be 3, 0, and of course there's no y-intercept, because that would mean that x would have to be 0, and that doesn't satisfy this equation. Here, the y-intercept is right here, so that's 0, -4, and there's no x-intercept, right? Okay. All right. So we'll make sure you're very comfortable. So every vertical line can be given by x equals some number. Every horizontal line can be given by y equals some number. Okay. On the next page, we're going to sharpen our algebra skills, and we're going to be showing how to solve linear equations in one variable. And basically, a basic idea is you want to break things down, multiply things out, and then put all the terms with a variable on one side and everything else on the other, and then simplify and then divide by something. So in this case, we're solving for x. Let's say we wanted to find what this equation is. Solve this equation for x. First thing we should do is multiply out this 3. So this will be 3x minus 3 times 1 is 3. And we have 4x equals 12. Now we'll add 3 to both sides, like so. And we have 3x plus 4x, that's 7x. And 12 plus 3 is 15. And at that point, we can just divide both sides by 7. So x is going to be 15/7. Okay, and it's okay with me if you leave it like this. You could plug in your calculator and you'll get a decimal, and then we have to worry about how many places do I round it to. So unless I give you specific instructions, you can just leave your answer like this. This is called an improper fraction, but that's just fine for our case. Okay, let's look at this next one now. x over 4 minus 7 halves equals 1/4. Okay, yes, we need fraction. We have fractions. There are a number of ways we could do this, but why don't we just, you'll see that there's only one x term here. So, and this really is the same thing as 1/4 times x. So this is 1/4 times x minus 7/12 equals 1/4. We can add 7/12 to both sides. Okay, so that means 1/4 x is going to be 1/4 plus 7/12. Okay. Now next we can add these two fractions. If you remember how to add fractions, we need a common denominator. And since 12 is 3 times 4, we can take this 1/4 and multiply and divide by 3. So then we have 1/4 x equals 3 over 12 plus 7 over 12. Okay. And this actually, if we go up here, we get 1/4 x equals 10/12. All right, now at this point you could simplify, you reduce to lowest terms, or we can hold off a little bit. We really want to solve for x, so we'd like to get rid of this 1/4. What we can do is you could divide both sides by 1/4, or you could multiply by the reciprocal of 1/4, which is 4. And either way is fine. Okay. In fact, when you divide by 1/4, that's the same thing as multiplying by 4. So why don't we just multiply both sides by 4, and then these cancel, and we'll get 1 times x, which is x, and this will be 10/12 times 4, and with 4 we can always write as 4 over 1, so x will be 40/12. And now we can leave it like this, or we can realize that 40 is 4 times 10, and 12 is 4 times 3. So the 4's would cancel, and we get x equals 10/3. Okay. All right, and finally, let's look at some more very generic equations. Here we have a relation between three variables, a, b, and c. And what way we do this is once we identify which variable we're solving for, we're just going to treat all the other variables as if they were just numbers or constants. Okay, and the whole thing is the idea is to get everything on it. Isolate. If you're solving for a, you want the a on one side. Okay, so we see we can do that. We take a plus 3b equals 5c. We can bring the 3b over to here by subtracting 3b from both sides. And then a plus 0 is equal to 5c minus 3b. Right? Let's look at for b. If we wanted to solve for b, what we could do is we'd like to isolate this term. This is the only term with a b in it, so we'll subtract a from both sides. So we get 3b equals 5c minus a. And then, because this is 3 times b, we can divide both sides by 3. And then the 3's cancel, and we get b is 5c minus a over 3. And then finally, if we wanted to solve for c, well, there's only one c term, and this rate is already isolated. So all we have to do is to get rid of this 5, and we do that by dividing by 5, both sides by 5. So a plus 3b over 5 is equal to c. All right. So this is just some basic algebra. The more examples and the more practice you do, the better off you'll be. So hopefully this helped, and we'll see you next time.